Examples using the Pythagorean identity. So, number 7. Given that we know the cosine of theta equals 3/5, find the sine of theta and the tangent of theta. Now, in order to do this, we're going to do two options. Okay, so we're going to have option 1, and we're going to split the page, and we're going to have option 2. Now, option 1 is we're going to use the Pythagorean identity. Option 2, we're going to draw a picture. So, starting out, we are given that the cosine of theta equals 3/5, and we're going to have to find the sine of theta. If I'm looking at the Pythagorean identity, we know that the cosine squared theta plus the sine squared theta equals 1. I'm going to start substituting what I know. I know that the cosine of theta is 3/5, so I'm going to take 3/5, I'm going to substitute it for the cosine of theta. But keep in mind that that's the cosine squared theta, so we have to square it. Plus sine squared theta equals 1. Now I'm trying to find the sine of theta, so we're going to solve this thing. So 3/5 squared. 3/5 times 3/5, 9/25, plus sine squared theta equals 1. In order to get sine squared theta by itself, I'm going to subtract 9/25 from both sides of my equation so that that'll cancel out. And then I'm going to be left with sine squared theta equals. You can either do 1 minus 9/25 in your calculator, or you can think about it as like 1 is 25 over 25. So then 25 minus 9 is going to give me 16, which is going to give me 16/25. At this point, I've got sine squared theta equals 16/25. In order to get rid of a squared, we square root. So sine theta, square root of 16 is 4, square root of 25 is 5, so the sine of theta, 4/5. Last thing we have to find using option 1 is the tangent of theta. Well, if you go back and reference the notes we just took, we said that the tangent of theta is the same thing as y over x. And then we filled in a little more, and we said that y is the same thing as the sine of theta, and x is the same thing as the cosine of theta. So now I know that the sine of theta, you just figured it out, is 4/5. So if I'm trying to find the tangent of theta, I'm going to put 4/5 in my numerator, divided by the cosine of theta, which we started with, was 3/5. Then at this point, you can use your calculator, just stick it in. Make sure you're using parentheses if you are going to use your calculator, or that you have a nice neat fraction, or dividing fractions, copy, dot, flip. So that's also called multiply by the reciprocal. 5s are going to cancel, straight across the top, straight across the bottom, 4/3. So the tangent of theta is 4/3. That is option 1. You can use your Pythagorean identity. Option 2, and I think you're really going to like option 2, draw a picture. So the picture we're going to draw, we're dealing with right triangle trigonometry. We're going to draw a right triangle. You have to label your reference angle. So I'm just going to put it down here. Whatever you do, it doesn't matter where you put it, just don't put it right here. That's the 90. So in the given, we are given that the cosine of theta is 3/5. And if you remember cosine, cosine is your ca, which is adjacent over hypotenuse. Which means, if we have a cosine of 3/5, that 3 must be the adjacent, and 5 must be the hypotenuse. So from theta, I'm going to make my adjacent side 3, and I'm going to make my hypotenuse 5. So I'm looking at my triangle. The only thing I don't know because I don't know that side right there. Easy way to find that side? Pythagorean theorem. So 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25. X squared equals 16. X equals 4. Back to the picture. 4. Now we are trying to find, we found the cosine of theta that was given, but we need the sine of theta, and we need the tangent of theta. Well, if you remember sine, that's so, O-H. So from theta, opposite side, 4. Hypotenuse, 5. 4/5. And compare that to what we have over here on the left-hand side in green. Same thing. Tangent of theta, TOA, O-A. So, we already know that the opposite is 4. Adjacent is 3. 4/3. And then come the whole way back down here. Compare that to the red, 4/3. And that's how you would do it if you're going to draw a picture. Last example. Given that the sine of theta is 5/13, find the cosine of theta and the tangent of theta. So you can pause the video, you can use option 1, you can use option 2, it's completely up to you. I know teaching this in the past, most people are going to pick to draw a picture, so that's what I'm going to do. Drawing a picture. Right angle. You can label theta anywhere you want it, but again, it better just not be the right angle. I'm going to put theta down here. So, ka, toa. They gave us sine. Sine is so, which means opposite and hypotenuse, which means this must be my opposite, and this must be my hypotenuse. So from theta, opposite, hypotenuse. Then we've got to figure out our missing side. 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. Take 169 minus 25. X squared equals 144. Take the square root. X is 12. Come back to your picture. 12. And then I'm going to label that adjacent. Okay. We have to find the cosine of theta and the tangent of theta. I'm going to start with the cosine of theta. Ka, A-H. Again, remember, you better be labeling everything. If you just write a fraction down, I don't know what it is. So, cosine of theta, AH, 12 over 13. Last but not least, tangent of theta, TOA, OA. So, opposite over adjacent, tangent of theta, opposite over adjacent, and you're done.